The Sumerian astronomer who logged something that wasn't a planet. Imagine doing the same job every single night for 30 years. You climb the same stone steps to the same rooftop terrace. You set up your instruments. You watch the same 5 wandering stars cross the same sky. And every morning before dawn, you press a stylus into wet clay and write down exactly what you saw. That was the life of a Babylonian astronomer, not glamorous, not mysterious, just a highly skilled professional doing a precise, repetitive job that his city depended on. Now imagine that one night something shows up that isn't in any of your training, something that doesn't belong. And you, a man whose entire career has been built on accuracy, write it down anyway, and then never mention it again. That's what happened. We have the clay tablet, we have the entry, and the more closely researchers look at it, the less comfortable they are with the obvious explanations. If this kind of thing interests you, hit subscribe. Every week I look at the ancient world and ask the questions mainstream history tends to avoid. You'll want to stick around. Now let's go back about 5,000 years and meet the people who first mapped the night sky, the most careful observers in the ancient world. The Babylonians, who inherited most of their knowledge directly from the earlier Sumerians, were not casual stargazers. They were professionals, trained from childhood, employed by the temple, paid to watch the sky every single night, rain or shine, and record what they observed with absolute precision. They tracked 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn. Every night they logged where each one was in relation to the fixed stars, how bright it appeared and how fast it was moving. Modern astronomers have checked these ancient records against computer models of what the sky actually looked like thousands of years ago. The results are startling. The Babylonian scribes were accurate to within fractions of a degree, night after night, century after century. This matters because when you understand just how careful and consistent these men were, what happened on one particular night becomes very hard to dismiss. The tablet. There is a clay tablet in the British Museum collection known to scholars as the Planisphere, catalogued as K8538. It was found among the ruins of the Great Library of Nineveh in the mid-1800s, and it took well over a century to fully decode. Here is why it was so difficult. The tablet is divided into 8 wedge-shaped sections, each representing a portion of the sky. It records star positions, planetary movements, and atmospheric conditions, all standard. But embedded in the astronomical data is a specific date. 2 British aerospace engineers, Mark Hempsel and Alan Bond, after years of careful analysis published in 2008, identified that date as the night of June 29, 3123 BC. On that night, the tablet records the usual planets in the usual positions, but it also records something else. An object moved across the sky at a low angle, moving fast. It is described in terms the scribe normally reserved for objects at the very top of his brightness scale, and then beyond it. He noted its path. He noted its size relative to the moon. He noted that it was visible long enough for observers in a southern watchtower to see the shadow it cast on the ground below. Then the next night's observations begin. 5 planets, in order, business as usual. He wrote it down and kept going. That's what professionals do. What was it? This is where things move from documented history into careful speculation. And it's worth being honest about which is which. the documented part. There is a real geological site in the Austrian Alps, a mountain valley called Köfels, where something violent happened a very long time ago. The valley contains a massive deposit of shattered, fused rock covering 12 square kilometers and reaching depths of hundreds of meters. For decades, geologists assumed this was a landslide. Landslides, however, do not fuse rock. The pressure required to produce what is found at Köfels is far beyond what any natural rockfall can generate. A growing number of geologists now believe Köfels was hit, or more precisely grazed, by a large asteroid or comet fragment entering the atmosphere at an extremely shallow angle. Not a straight-down impact, like you might picture, but more like a stone, skipping low across water before hitting the surface. This kind of event would produce an enormous explosion without leaving a traditional circular crater, and that explains why Köfels looks the way it does. The speculative part. Hempsel and Bond calculated the trajectory recorded in K8538 and found it consistent with an object that entered the atmosphere from the northwest, traveled southeast across Europe, and struck the Alps at Köfels before the remaining fireball continued toward the Middle East. If their reading of the tablet is correct, and it is a serious, peer-reviewed piece of work, not fringe theory, then the Babylonian astronomer was not watching a comet pass harmlessly by. He was watching the first minutes of an impact event. That part is genuinely uncertain. Other researchers read the tablet differently. The debate is ongoing and legitimate, but the trajectory math, if the tablet means what Hempsel and Bond say it means, points directly at Köfels. What happened on the ground? Here's something that doesn't get discussed nearly enough in connection to this tablet. Around 3100 BC, which lines up with the 3123 BC date within the margin of archaeological dating, something went wrong across a wide stretch of the ancient Middle East. Cities that had been continuously occupied for centuries were abandoned. Agricultural systems collapsed. Population centers that showed steady growth through all previous periods simply went quiet. Archaeologists call this transition the end of the URUK period. It is treated, fairly enough, as a complex event with multiple causes: climate, politics, trade disruption. All of these likely played a role over time. But there is a physical detail buried in site reports from excavations across the region that rarely makes it into the summary discussions. At multiple sites separated by hundreds of miles, archaeologists found the same thing at the same depth: a layer of burnt and scorched material. Not evidence of a local fire, a simultaneous burn layer across an enormous geographic area, all dating to roughly the same point in time. One burn layer, covering a region the size of Western Europe, all at once. Is this connected to the object in K8538? Honestly, we do not know for certain. The evidence is suggestive, but not conclusive. What we can say is that a 500 megaton impact event, a conservative estimate of what the Köfels strike may have produced, would have created exactly this kind of regional burn signature across the Middle East. The fireball traveling southeast from Austria would have passed directly over the Fertile Crescent. That connection deserves more attention than it currently gets. The astronomer himself. We don't know his name. Ancient Mesopotamian scribes were professionals, not celebrities, and most worked in anonymity. But we can piece together something of who he was from the tablet itself. His handwriting, according to cuneiform specialists, is steady and practiced. This is a man who has pressed thousands of identical entries into clay. The entries before the anomalous one are routine and confident. The entry for the unusual object uses the same measured, precise language as everything else, with no signs of panic or excitement in the writing style. He simply described what he saw as accurately as he could, with the tools and vocabulary he had. That's actually remarkable. Whatever he was watching, he did not run. He did not stop writing. He observed it, recorded it with the same professional care he gave to Saturn's retrograde motion, and filed it. Then he went back to work. Whether he understood what he was watching, whether he had any sense of what it would do when it left his sight and continued southeast, we have no way of knowing. Possibly he reported it to the temple administrators and they decided how to handle it. Possibly it was discussed and explained away somehow. Possibly he died not knowing. What we know is that he did his job. On one of the most unusual nights in human history, a trained professional was in exactly the right place at exactly the right time, with exactly the right skills to write it down. And because he did, we still have the record. Why this matters. There is a tendency to think of ancient people as less capable than us, less observant, less precise, less reliable as witnesses. The cuneiform astronomical logs are a direct argument against that idea. These were skilled scientists doing demanding, technical work. When their records are checked against modern calculations, they hold up. When they logged something unusual, they were not making it up or misremembering. They were writing what they saw. So when a Babylonian astronomer on a specific night in 3123 BC inserts a sixth object into a 5-planet log and marks it as beyond his brightness scale, and notes the shadow it cast on the ground, the most reasonable starting assumption is that he saw something real. What it was exactly, and what it did after it left his sight, is still being worked out. Hempsel and Bond's research is the most detailed attempt so far, and their findings are worth taking seriously, even if the full picture is not settled. The tablet is real. The astronomer was real. The night was real. Whatever crossed the sky that night was real too.